Assalamu alaikum. Welcome to my YouTube channel. Today in chemistry I am going to teach stoichiometry, that is calculations in chemistry, and in stoichiometric calculations I am going to talk about percentage composition. So in this lecture I will explain how to calculate percentage composition, and in my next lecture I will also explain percentage yield. I am preparing this lecture specially because some of the students, they sent me email that we want to understand percentage composition and percentage yield. So let's start. Suppose for understanding percentage composition, I will give an example of sodium chloride. Sodium chloride, the formula of sodium chloride is NaCl. It is the common salt which we use in food. So in sodium chloride, the atomic mass of sodium is 23 and the atomic mass of chlorine is 35.5. So when we will add these two, so we will calculate the molar mass or formula mass of sodium chloride, that is 58.5. So here 23 plus 35.5 is equal to 58.5. This is the molar mass or formula mass of sodium chloride. Now how I will find the percentage of sodium? It is the short form of percentage. We will put the sign of percent and then age, percentage of sodium in sodium chloride. So what is the formula? Mass of sodium divided by mass of sodium chloride multiplied by 100. So for calculating percentage of sodium in sodium chloride, I will write the mass of sodium in the formula here and the mass of sodium chloride as denominator, multiply by 100. So here the mass of sodium in this formula is 23 divided by the total mass of sodium chloride, that is 58.5. Total molecular mass or formula mass is 58.5 multiplied by 100. So when we calculated, we found that the percentage of sodium in sodium chloride is 39%. So I will write percentage of sodium in sodium chloride, percentage of sodium in sodium chloride, it is 39%. Now if we want to calculate the percentage of chlorine, also we want to calculate the percentage of chlorine as well in sodium chloride. So what we will write? We will write the mass of chlorine here as denominator and mass of sodium chloride as denominator. So 35.5 divided by 58.5 multiplied by 100. So it will become 61%. So this is the percentage of sodium and this is the percentage of chlorine in sodium chloride. So, and in order to verify that you have done all the calculations correctly, so add all the percentages of all the elements. So it should be 100. It should become 100. For example, here the mass of sodium is 39% and the mass of chlorine is 61%. So when you will add these two values, it will become 100%. 39 plus 61 becomes 100. It means that our calculation is correct. Now let's take another example, that for instance we are asked to calculate the percentage of carbon in glucose. This is the formula of glucose. I took another example. Glucose, it is a type of carbohydrate which has three elements: carbon, hydrogen and oxygen. Where carbon has, in glucose, there are 6 atoms of carbon, there are 12 atoms of hydrogen and there are 6 atoms of oxygen. So that's why its formula is C6H12O6. Remember, this is the formula of glucose. So if someone asks us to find the percentage of carbon in glucose, find the percentage composition of carbon. So how we will find out? So for calculating percentage composition, we must know the formula mass or molecular mass or molar mass. So first of all, I will calculate the formula mass or molecular mass of glucose. So glucose, its formula is C6H12O6. How many carbon atoms are there in this formula? 12 carbon atoms. So what I will write? So I will multiply, here the number of atoms are 6. How many carbon atoms are there? 6 carbon atoms in glucose and 12 hydrogen atoms and 6 oxygen atoms. So I will multiply the atomic mass of carbon, which is 12, multiplied by 6. Why I multiplied it by 6? Because the atoms of carbon in this formula are 6. So mass of carbon, atomic mass of carbon multiplied by 6 plus, now come to this, the atomic mass of hydrogen is 1, multiply by 12. Why multiply by 12? Because there are 12 hydrogen atoms. That's why I multiplied it by 12. So this is the portion of hydrogen. Now come to oxygen. So oxygen, the atomic mass of oxygen is 16 and I multiplied 16 by 6. Why? Because there are 6 oxygen atoms in this formula. So considering this, I will multiply the atomic mass of oxygen by 6. So it will become 180. So 12 multiplied by 6 plus 1 multiplied by 12 plus 16 multiplied by 6. So it becomes 180. This is the molar mass or molecular mass of glucose, that is 180. Now we will come to the percentage of carbon in glucose. So as we know, what is the portion, what is the contribution of carbon in glucose? That is 6 carbon. So we will write the atomic mass of carbon multiplied by 6 divided by 180 divided by total molecular mass of glucose. So multiply by 100. So mass of carbon in the formula divided by the total mass of the formula multiply by 100. So it becomes 40%. It means that in glucose the percentage of carbon, the share of carbon is 40%. So I will repeat that overall, what is the formula of percentage composition? That write down the mass of that element in the compound, the share of element in that compound here above divided by the total mass of the formula, the total mass of the molecule, the total molecular mass, whatever you can say, multiply by 100. In this way you will find the percentage of that element in that compound. For example, percentage of sodium in sodium chloride, percentage of chlorine in sodium chloride, and percentage of carbon in glucose. So this is about percentage composition. I hope you have understood my lecture. So at the end, I will request that please subscribe my channel and share it with other students. Thank you very much.